So we need to be able to look at a graph and determine continuity. And from the graph, it's pretty straightforward if it's continuous or discontinuous, right? If it breaks apart, it's discontinuous. If it goes through, okay, it's continuous. Okay, so it's going to be, if I have to lift my pen here to go over that hole, we consider that a discontinuous point of discontinuity. We also should give a statement of why it's discontinuous. Okay, so at x equals -8, okay, clearly that I have to jump there to get to be able to draw that through. So we can say that this is discontinuous. And we should really give some sort of statement. So in this case, the limit as x goes to -8 of f of x is not equal to the limit as is not equal to the actual value at -8. Okay, so we can kind of, from that we can determine that's really a hole. At 6, again, it's discontinuous. Okay, the reason is the limit as x goes to 6 from the positive side of f of x is not equal to the limit as x goes to the negative side of f of x. Okay, that statement gives us an idea that it is a gap discontinuity. At 10, it is continuous. Okay, if we look at, it just draws straight through. It's continuous. Okay, so the criteria that we need for continuity is the limit as x goes to 10. Not only does it exist, but it's equal to the y value at 10. So there's no hole or gap in there. All right, for Newton's quotient, we need to be able to set up the Newton's quotient, okay, and be able to use a limit to find a derivative. Okay, we don't need to do this all the time, only when it specifically says show the Newton's quotient. So Newton's quotient is basically finding the slope, okay, finding 2 points, the rise over run, and letting the run go to 0. And that gives us an instantaneous slope. So the derivative can be determined by setting up a limit as h goes to 0, and we want to move that point away from x just a little bit, h, and let that run of h go to 0. Okay, and as we do that, we have the rise. We'll see what the ratio of the rise to the run is as we approach 0. So for this one here, there's basically 3 types. There's the square root type, the polynomial type, and the 1 over x type. So make sure that you have an understanding how we can algebraically work out these limits. So here we want to get rid of this square root. So we want to use the conjugate square root. Okay, so if we use the conjugate, x plus h plus 2 plus root x, what we end up with is a difference of squares, and the difference of squares will get rid of the square roots of the numerator. And by doing that, we free up that h in the numerator, and hopefully we can get something that cancels out, and we'll end up with some factor of h. So this then works out to be, this should be plus 2 here. I forgot a plus 2, didn't I? Okay, so there should be a plus 2 in here. There should be a plus 2 in there. Plus 2, plus 2. Okay, so there it is. Multiply that out. I'm going to end up with a difference of squares. So I end up with a limit as h goes to 0 of x plus h plus 2 minus x plus 2. The x and the plus 2's cancel out. Okay, we end up with, in the denominator, x plus h plus 2 plus square root of x plus 2. The square root and the h in the denominator is okay because this one here is not a factor, so it's not dividing by 0. This is the one that's the problem, but that cancels out. That cancels out. We end up with h over h, so we end up with that h canceling out as well. So we end up with h on top, a factor of h on bottom, x plus h plus 2. Okay, there it is. Those cancel out. Now we've gotten rid of that divide by 0. I can plug in 0 into the denominator, and I end up with x plus 2 square root plus x plus 2 square root. So we have 2 square roots of x plus 2. And the power rule would also confirm this derivative.